Well, hey guys, today we are talking about soccer balls. Not just any soccer ball, this massive big soccer ball over my shoulder. Well, we're not really talking about soccer balls. We're talking about the solid that is the same shape as this. It's a three-dimensional solid, and you probably have heard of this before. It's called a sphere. So it's like a circle, but in three dimensions. It's think of the Earth is like a sphere, or the moon, or a soccer ball, right, in this case. So a sphere has a volume and a surface area. So let's look at the formulas for those and talk a little bit about how we can calculate them and the kind of questions you might get asked. Looking at my sphere, I can see around the outside of it, it's got a very familiar shape, and that is a circle. We know that circles have a line or a distance that runs from the middle to the edge, and we know we call that the radius. In this case, I'll call it little r. All right, so looking at my little diagram here, I can see I've got a radius, and I'm going to use that value to calculate the volume. In other words, how much space there is on the inside of this sphere. Now, luckily for you, if you're doing Year 11 Standard Maths in New South Wales, you don't need to memorize this. This formula is on your formula sheet. But the volume of a sphere is 4/3, so 4/3 times pi times the radius cubed. So long as we know the radius, we're good to go. We substitute the value in where the r is, and we can calculate the volume. So here's an example. The volume of this sphere. Now, looking at it, the center point of the sphere. So here it was a circle, but thinking about this now in three dimensions. Okay, so the center point is right where this little red hand is pointing to. It's at the center of the sphere. And the radius goes from the center of the sphere to the surface. In this case, 7 meters. So all I need to do is substitute that value, a radius of 7, into my formula. Now, if you've watched many of my videos, you know that I like to encourage you guys to put a set of brackets where the letter was and insert the value into it. You can type that straight into your calculator, as you see, with the brackets and all. So when you put it into your calculator, you're going to get a value of 1436.8. Don't forget, the volume is cubic. So my index here will be cubed because we're talking about volume. So in this case, it's meters cubed. What about the surface area? Now, by the surface area, looking at my soccer ball, it's the black and white skin on the outside of it. Okay, the surface area is the area on the outside. If I was to paint this ball another color, all the bit that gets touched by the paint. Well, we have a formula for that as well. Once again, it's on your NESA formula sheet. The surface area of a sphere is simply 4 pi r squared. So once again, if I know the radius, I can substitute that in, and I get a value in my calculator of 615.7. So they're not hard. If we know the radius, in other words, the distance from the middle of the sphere to the edge, then we're good to go. We've got everything we need. However, the questions don't always just come so straightforward to you, right? You might get something like this. What if we wanted to work out the volume and the surface area of this shape here? Now, this is like a sphere that's been cut in half. Think of like a dome. Think of like a snow globe. You know, it's kind of flat on the bottom, and it's got the round bit on the top. So in this case, we've got a sphere, but we've only got half of the sphere. So let's go through and have a look at how we might attack this if we needed to know the volume and the surface area of this dome. Well, the volume bit is pretty straightforward. This bit in the brackets here is what we had if it was a full sphere. 4/3 times pi times the radius cubed. Okay, but it's not a full sphere. We only want half. So I need to take a half of that value. So I can either divide it by 2, or in this case, I multiply it by a half. I get the same result, put it in my calculator, and I've basically just chopped our answer from the first question in half to get this value here. All right, so far so good. What about the surface area though? Now there's a little twist here to watch out for. Once again, I've got to get surface area, which is half of the soccer ball, or half of the sphere. So I take my 4 pi r squared and I halve it. Okay, that gives me the surface area of this curved piece, like the top part of the dome. But I also need to include the flat bottom, and the shape of that flat bottom will be a circle. So if I chop my soccer ball fair in half, that bit that it gets chopped will be a circular shape. So I have to do the area of that piece as well. In this case, the area of a circle is pi r squared. So I've got to do pi times the 7 squared. If I put all that together, so I've got to add together the curved bit and the flat circle on the bottom, stick it all in my calculator, and I'm going to get a value of 461.8. So be really careful when you get a question like this to have a look and see, is this a surface area or a volume question? Because if it's surface area, I've got to consider the flat part on the bottom. All right, fair bit in that, guys. Good job. Well done.